presentation, I've got a Raspberry Pi. Because the problem with this MacBook is that it has 16 gigs of RAM, so it doesn't make for a very effective demonstration of how slow operations are when you're operating from disk, because it'll just cache the entire database and then it doesn't seem so bad. But when I can show on a 256 megabyte system that has low I/O that it takes over 2 minutes to do a simple query, it's a little bit more effective as you know, like why this technology is cool and what makes it awesome. Let's see if we can arrange this a little bit better.
She should be able to.
Okay, cool. So let me get back to where this thing was. Yeah, this one. Alright, so if you want to follow along, I've got 3 repositories up that all have a little bit of the information on them. And so I'm going to be going through the 3 of them. And can everybody do this clearly?
Yeah, I'm doing
turn off the lights a little bit.
Unless one of you guys know how.
No, I don't know.
Let me dim the lights a little bit. Or all the way. How do I? Yeah. There we go. That's better. Okay, maybe those 2 then. Thanks. Sorry. Okay, so
My first pleasure today.
who has used SQLite before? All right, so maybe half of you. Who has not? I think that's the other half. Okay, cool. All right, but have you used other databases before, like MySQL or Postgres or something like that?
MySQL.
Oh, yeah.
Is there anybody in here that has not used a database before, relational database before? Okay, good. I'm glad to hear that because that makes me feel like this will be productive because I didn't really want to spend a lot of time on how that works. Was anybody in the session yesterday that was search algorithms to answers? Okay, so that stuff that he was talking about with Lucene is directly applicable to this. So, let me get out my Raspberry Pi here so we can do this demonstration. But what I've got is all of the logs from the, I can't use that because I have to use this, so that doesn't have anything. I have all the logs from the Haskell IRC chat from the past 10 years because I just figured, like, well, where can I get a heck of a lot of data that would have interesting stuff to search in it? And, you know, all sorts of stuff goes on IRC, and you've got those that run for years and years. And so I just searched for IRC logs, and one of the first top hits was somebody's log server that had a bunch of different languages on there, and then I picked the Haskell one because it was the largest and the longest running, or one of the largest running. Anyway, so if you may be able to visit this site, which you can get to by searching Coolage86 SQLite FTS demo. Should take you right here on GitHub. The actual URL is /Coolage86/SQLite-FTS-demo. But if you want to follow along, you can download the data.sql. It'll take a few minutes to download. It's like almost 300 megabytes. And it'll take a few minutes to bunzip as well. But that's where the file that I'm using is. And then also you need to use the latest version of SQLite to be able to do this stuff. Although the latest Ubuntu does have a version of SQLite that contains full-text search. Full-text search is something that's actively being worked on now, and so every couple months they come out with a new version that is perhaps a little bit better, has a few more features. I believe that for this demo, I'm using features that require at least 3.7.13, but for the demo I was using 3.7.14 when I did this before. So, yeah, you may have SQLite already installed on your system, and installing this could conflict with that, because then when you start up, you get just X out of some of these things, probably. Where I was searching for there's this problem that you get where it says something about the wrong library located. I wish I put that in here. But so what you'll actually need to do is probably something along the lines of, I think, down here towards maybe the appendix area. I think I put it in here. No? Oops. RM. Oops. RM. Nope, it wasn't in this one. Maybe it's in this one. Oops. It's in this one. Okay, here we are. So you might have to do something like this, where you just get rid of all existing library files that you have on your system, which might bork some things or might not. I've only tried this on VPS and Raspberry Pi. I think I've done it on my Mac as well. I think I had to remove the version that came with it. But it's a mismatch between the binary SQLite3 and then the library SQLite3. Because SQLite3 is actually more of a standard than it is an application. So the binary that ships with it, that uses the library, is not so much like a server as it is a reference implementation in C of the standard. And the library is something that you can link to from JavaScript or Python or Ruby or whatever, and then be able to use that standard implementation. But there is no server, it's just file access. So that's a little bit about SQLite and the installation of it. So where I go to download it, if you just Google SQLite download, you'll get to SQLite.org/download, and I use the SQLite AutoConf version, and then untar that, and from there it's your standard /configure make and sudo make install to get it in there. And once we have those couple of items, then we're set to start. And I do have them already. So let me just make sure I can log into my Pi. One should have some sort of problem. Or just take too long, or have some sort of problem. Make sure this is all plugged in. Good. Got network connection. So who can give a little bit of an explanation about what SQLite is, real quick? Anybody? Yes?
Relational database in pure C, very embeddable, and public domain.
Okay, very good summary. Anybody have anything they want to add to that?
It's not necessarily a server, it's an app that really accesses files locally.
Yep.
It's not even an app, but yeah.
All right. Good. So, yeah, it's a lot like MySQL or Oracle or MS SQL or any of the other SQL type databases. It also doesn't follow the SQL spec, just like all of the other databases, except differently from any of the other databases. So you have that awesome congruency of knowing that SQLite is different from every other relational database, just as much as every other relational database is different from every relational database. So same thing there. Nothing to worry about. The cool thing about SQLite and the full text search is who's ever done a query on a database where you're doing that table scan, where you're looking for some text, like perhaps a description in a bug tracker type deal, and you're doing a select star from bugs where description like quote percent USB something percent quote semicolon, and it's maybe taken a while. Has anybody had that experience? With a couple hundred rows, you don't really notice. It's like BOGO sort is actually a decent algorithm up until about, I think, 8 items. But up until 8 items, it's still under a second, so you know you're good. And likewise, it doesn't really matter what kind of query you're using when you're just doing a couple hundred items that you're searching through text. But when you get bigger, and especially when you get bigger and smaller, right? Like, so I'm going to demo this on the Raspberry Pi if I can ever figure out why it's not connecting. I promised I did try this morning, this morning, and it was working before I came in. So I apologize for it not working, but I promised that I was prepared. I did test it. It did work. Maybe I just need to turn off internet sharing and turn it back on again. And then go to network, unplug this, unplug this. And if I can't get this working, I can do it on my Mac. It's just you won't really see the difference. But the question, what is the scenario where we would want to use full text search? Why isn't plain old SQL good enough? How does FTS shine? How does it solve the problem in a unique way? So to show this, we'll demonstrate Godwin's law, which is that as an online discussion grows longer, the probability of a comparison involving Nazis or Hitler approaches 1. So does that hold true for IRC chats? We will go ahead and just make this right here is a command to make SQLite in memory, so you're not actually creating a permanent database. You're just doing a fake one. Come on, you gotta be kidding me. How does it work? Let's try this. I don't like that. I don't like it okay. That I like. All right, cool. Now we're here. Excellent. Get rid of the stupid search things. Highlighting my R's. Maybe make that a little bit bigger. Is this clear to see? Is that plenty big? Yes. Okay. All right, cool. So I'm just going to operate on an in-memory database. This is just a special syntax to say don't use a file, use memory. And for just doing some simple stuff, for this demo, that's fine. So what I'll do is I'll just copy and paste this table in there. Actually, I'll do one better. I will make a table called, we'll make a folder called SQLite demo. And I will change it to that directory. And then I'll create schema.sql. So pretty familiar with any database you use. You shouldn't see anything special here. And then I will go ahead and go back into that in-memory database and then call .read, which is special to SQLite, and then give it the path to the commands that it's supposed to read in. And now if I do .schema, I should have done this before, so you can see it was empty. But .schema just returns back usually exactly the text that you've entered, because when SQLite interprets the table schema, it doesn't actually create tables in the same way that MySQL does. It does more of a Berkeley DB type approach where it's a key value store and then it does some fancy magic. It's like what MySQL 4 was as opposed to MySQL 5, which is much more optimized and not as straightforward key value pairing. And then these things I will just copy and paste into here. These are actual conversation bits that I took from the logs. And just for reference sake, I think what I Googled was IRC logs. Let me try Haskell. I don't remember what it was, so never mind. I think it's in the appendix, in case you're interested in where I got this from. But I just have it formatted, all SQLite, and now it's inserted. So if I do a select, whoops, oh, I don't like that at all. What an awesome terminal to use. Select count from, I think the table is called logs, right? Make sure that that's right. Yeah. Cool. So we can see 7 records were inserted, nothing too fancy here. If I go ahead and pull it all out, you can see there it is. Pretty normal format, similar to what MySQL puts out. And then, just for fun, here's how you concatenate in SQLite. You use the double bar character. So now I can put it back out in the original format, but it wasn't. And now I'll do a really simple query that just contains messages that have hi in it. So let me expand this out a little bit. Let's see if the dot clear work. Dot help. Is there a dot clear? Something like that. Dot good. I thought there was a dot clear or something that would make the screen buffer go away, but I can try this way too. There we are. Okay, we'll do that again, and you can see that there are messages that have hi in them. Can anybody just explain real quick what is going on here, what the magic that's happening is? Just for the sake of clarification. Yeah.
Doing a wildcard search on the one column called message, if that contains the string I.
Yeah. Yeah, so it's
anywhere in the string, right?
Hmm?
Yeah, anywhere in the string.
Anywhere in the string, yeah, because it's got the wildcard, which is the percent sign. And in terms of search speed, what does this mean? Like, what is actually happening as this search is taking place?
Full table scan.
Yeah, it's full table scan. More specifically, it's looking at one row in the table, and it's starting at character 0, and it's checking to see, does this character match H? If not, move to character 1. Does this character match H? If not, move to character 2. So the big O of this is going to be the number of characters in a row, on average, times the number of rows. That's what the search is. So that's for our 7-row table, not a big deal. It goes through super quick. Let me just go ahead and, well, I won't bother timing it. It's 0.00 milliseconds. Or something close to that, 0.012 or something. It's at least 0, or at most 0.0. So now, the problem is when we get some bigger data. This data that I'm about to show you took, let me go into here, SQLite FTS. Oh, where is my folder? Oh, it's Haskell. Great, there we go. So the time it took for me to create, what I'm going to open up is archive.noindex.sqlite3. That's my binary database file. And if we look at noindextime.log, it took 64 minutes and 34 seconds on this machine to bunzip and import all of that in SQL. So that's why I was testing this beforehand, because it would not be a good presentation. Because on my Mac it takes about 5 or 6 minutes. And so I was like, oh, maybe it'll just take like 20 minutes on the Raspberry Pi. That's worth doing beforehand. But then it took an hour. So I'm really, really glad I did it beforehand. But yeah, so that's a long time. That's just to read in the data. But then the search time, let's do a really simple search here. So we're skipping these parts down to right here. So I'm just going to take a count of every time there's a message that references Nazi. Maybe I should make this a little smaller or something. A little bigger. Or a little bigger and smaller. Get this whole thing on the line. Great. Yeah, so I need that in quotes. So I'm using the time command just so we can see how long this takes. No such table logs. Liar. Oh, because I need to correct the name. And actually, I don't want to do the count because then I don't get to see progress. So let's watch progress. So as it's going over, I think it's 1.2 gigabytes extracted data. I believe the number of records was about 2 million in total. It's going to take a while. Like, this is going through every single one of those 2 million records and byte by byte looking for a match on an in, then to see if it's followed by an A, and so forth. What do we say? Viewer discretion is advised because not all of these remarks are polite. Some of them are just kind of cute and funny, like grammar Nazi, ha ha ha, and some of them are a little less childish in the nicer sense of the word childish. But I just kind of want you to feel this pain. I mean, imagine if this were, imagine if you had a larger set of data that you wanted people to be able to search through. I mean, I think that it's kind of cool to be able to go through 10 years of logs and search at it. And I think that's useful. Does anybody else have some useful cases for large data where you're searching through stuff?
Wikipedia.
Wikipedia? Yeah, that's a good one. That's a really good one. Anything else? Do you know how many gigabytes Wikipedia is now, by the way?
I don't.
I believe that they offer a download on
You can download it. Yeah.
I believe a few years ago it was something like maybe in the range of 8.
They have an article on their size.
Wow.
42.
So 9 gigabytes compressed, 42 gigabytes uncompressed. Wikipedia, is that not the meaning of life, the universe, and everything? The ultimate source of truth?
Right.
This is no coincidence. This is how it was meant. This is fake. 42 gigabytes of data. Oh my goodness. Wow. Stalling for time. Just feel that pain. Feel it good. All right. Oh, it's a little bit faster this time than it was last time I tried it, because I tried it a few times in a row. This time it was under 2.5 minutes. So, anybody feel like that was a pretty good experience? We were able to take 10 years and compress it down to 2.5 minutes. Pretty decent, right? So, now I'm not going to run this because I ran the code or the little SQL query to convert it, and to re-index it took 54 minutes. And the indexing that I use, there's a couple different indexing options that the full text search has, but let me just show you here. It almost doubled in size. Well, not quite, but it got significantly bigger. It went from about 800 megabytes with no index to 1.3 gigabytes with all of the index features turned on. Note that you can turn some indexing features off, still have really great speed. I just decided to turn them all on, and it does add a little bit of bloat to the indexes. So I will show you what this schema looks like. So the table called logs is just a timestamp, a user, and a message. But the table that I just add to give this the full text search capability. This is how simple it is. You can either tell it that you want to use FTS3 or FTS4, and on their website, if you search SQLite FTS, it should come up with the SQLite FTS3 and 4, and it explains the differences between them, and it talks about a couple of the options for your queries and what you can do. So that's the in-depth information if you're interested in that. I just went ahead and used 4, know that that's going to use a little bit more space. It also depends on how big your documents are. If your documents are each 100 characters long, you're probably going to waste a little bit more index space than when your documents are a couple thousand characters long, because it's having to do more work per row. Or, yeah. So anyway, I create a virtual table. This is kind of special to SQLite. Other databases have virtual tables or something similar. But it says it's a virtual table, but it's not a virtual table in the sense that it's a stored query or that it disappears when you exit. It's just a virtual table in the sense that it's not actually a relational table. It's a full text table, but you're able to integrate it as if it were a regular table. So I created this one called logs_FTS. And then this directive right here is not standard SQL syntax by any means. This is just special to particularly the full text search option. So it looks a little funky. Some of this stuff will look a little funky. But what this is saying is that I don't want you to actually copy the index of the full text search. So if you were using SQLite over here and you were working some other database over here, you might want to have the copy of the content in the SQLite table instead of just the index. But this content equals logs means, hey, I already have the content. And I think you can also do content equals none or null or something like that. That would do the same thing if you did want to store it in separate places. But it says, hey, don't copy the content that I'm going to feed you for this. Just know that there's already a table that has the content. I just want you to do the index and not store any content in this virtual table. But then, because it's smart enough, when it goes to look it up again, it'll know that it needs to join the real table with the virtual table when it gives you the data. And then you specify which columns you want to have indexed. I don't care about indexing usernames or timestamps. I'm just going to have it index the message column. And then there's this really funky, weird syntax that just screams, what? And this is just a crazy hack, so they didn't have to introduce a lot of new syntax. They could just kind of use the existing internal functions that they have. So you insert into the full text search table the full text search table, because to be valid syntax, I think you have to put in a value. You can't leave it empty. And then in the value of that table, you put rebuild, which means look over the entire contents of logs, in this case, and then rebuild the search index. So that's simple enough. However, there is another caveat that you would need to be aware of when using this, which is that, oh, wait, what did I do? Oh, okay. If you do that, can anybody guess what happens when you go and insert data into the table? Maybe I should demo this. I think I have this part of the demo.
It doesn't update your full text index.
It doesn't update the index. Now, why they didn't make that automatic, I don't know. It may be because it was too difficult to work around the existing syntax and internal code. But they don't do that. So, oh, and I don't have the example of how that works here. But just know that if I were to insert stuff into this table now, it would not be indexed. So what I have to do is set up triggers. And all of this stuff that I'm showing you is pretty much on their documentation page. I've made a few tweaks, changed a few names of things, disseminated a few typos and corrected them and submitted it to the mail list. But this is pretty much, you know, if this information isn't enough for you, what I've got here, when you're looking back over this, just searching SQLite FTS, bringing you to that documentation page will give you the greater details that I gleaned from. So I'm creating a trigger, logs_BU, which just stands for before update, that happens before the logs table ever gets updated. And what it will do is delete, and this is just some magic. Doc ID is just a quasi-magic variable that you can use all throughout SQLite wherever you're doing a query. Despite what columns you have named, there's always a secret column called doc ID. And then in this case, where I'm doing an update, there's just this secret magic variable called old. And for some reason, there's a distinction between doc ID and row ID, and I don't remember exactly what it was, but I think in the full text table, it's called doc ID, and I think in the regular table it's called row ID. But I could access any field in that row from this old dot, so I could do old dot message or something like that. But anyway, it's saying delete from the full text search where the document IDs are the same. If I go to update something, and then after update, I have another trigger that's just doing the inverse. It's saying once it's updated, take the doc ID, and then B and C. I'm not sure if those are arbitrary or not. I don't remember. Might have to be called that. Sorry, I don't remember. But anyway, for whatever number of tables that you have specified in the FTS table, then you go ahead and say that you're going to add those values as well. So this time, before the update, you're deleting the index. After the update, you're updating the index. And same thing with the delete. When you go to delete, you want to delete the index. Because otherwise you could have a row that doesn't exist anymore, but when you do a full text search on it, it will still show up, but then it'll have null strings because the data that it used to reference isn't there anymore. So you just get superfluous rows of nothing. And then there is the after insert, which of course when you insert something new is going to add that new item to the search index. And then I just had it so that when I add the triggers, I go ahead and run the rebuild again. So now for what full text search actually means. What happens is as the data comes in, it gets tokenized. There's a default tokenizer. You can write your own in C. They have documentation on how to do that, and I'll show you a little bit of how to write a module for SQLite, and hopefully that'll give you a springboard if you decide you did want to use a custom tokenizer. But by default, I believe that the tokenizer is meant to work mainly with English, and it basically looks for non-punctuation characters in the Unicode set. So I believe all the Latin characters are Romanized. Sorry, I don't remember the details exactly on that. But the tokenizer has a couple different options when you look at the documentation page, and you can actually pass in, just like I did this content equals logs, you can pass in I think it's like tokenizer equals, and then you can tell it to use the default one, or you can tell it to use one of the other ones that's provided, or you can load your own before you run this command, and then have it use that tokenizer as a custom compiled C module. So in the basic case, just imagine you're stripping out all the white space and punctuation and separating the words. And I believe one of the options is so that it does what is it called when you do the grammar tree and decide what the base of the word is? There's a technical term for that. Anybody know it off? The root? Root. Yeah, you're finding the root word, something like that. I believe that's one of the tokenizer options as well. But it splits all of that up, and then it puts it into an index where instead of searching through 2 million records, out of those records, including misspellings, there's probably about 25,000 words. So we're taking it from 2 million records, which is quite a bit to search, 2 million records, which is doing a character-by-character search, and we're turning it into something where it's a sorted tree, even if you have to do character by character, even if you're looking for something like, the syntax for this actually becomes star instead of %. But even if you're doing the matching before and behind, it's still able to go through that tree pretty quickly. In the worst case, it has to go through 25,000 items. In the worst case. And that's not too many. That's pretty quick still. So let me just show, if you remember, the last query we did took how long?
2.5 minutes.
Yeah, it's 2.5 minutes. So let's see if we can do better with this query that is on the indexed one. Now don't blink, okay? Okay, did anybody blink? Because you might have missed that. Did anybody miss it? Okay. So now this went to 0.176 seconds. Improvement?
Yeah.
I mean, what is that? 0.2 of a second from 2.5 minutes? Like 600% or something like that? If only it was by 100 instead of by 60, I'd be able to calculate that pretty quickly. So what I found is, like, say that the system was just freshly rebooted and you don't have anything in the disk cache. Stale, that query takes about 1.5 seconds. And then fresh, it takes somewhere between 0.1 and 0.4 seconds. And part of the variation on that is whether or not you're outputting to the screen. Because actually echoing takes some time. So if I just repeat the same exact query that we just did, output to the screen, it's significantly slower. And if I do the same thing again, it's pretty fast. So there is some cost there in just having the stuff printed to the screen. So obviously, however much data you are pulling out, it's going to take longer because it has to do mem copies on each row. And it does have to look up the row and join. When I was just doing the count, it didn't actually have to fetch the document. But, I mean, you can see this is much, much faster. It's still having to go through every single word in the document, but it doesn't have to go through all 2 million sentences. It just goes through the 25,000 words, finds them really quick. And I believe we can make this even faster because when you do what I just did, where you are matching star, in the documentation, it talks about how that actually takes a little bit longer because the way that it automatically joins. You can do a custom join that will take less time than the automatic join. So this right here is the same as what we just did above, but instead of allowing SQLite to automatically join logs FTS to logs, we're going to be more specific and say we just want message, so it only needs to load that field. And we're going to tell it exactly how we want it to do the join. And so if I run this again, weird. Extra tabs? What? I'm so confused. Alright, I'm just going to paste that in. Okay. So that was really fast too. That seemed to be faster. Let me see if I just put this query in a SQL file real quick. And then I loaded the same. We loaded some of the other ones. also note that when I'm doing this timer with the SQLite3 binary, it does have to do some initialization every time. So it could be even a little bit faster than that if you're using it in your programming language where you already have it. You already have the library itself bound and loaded into memory every time. And it doesn't have to reinitialize. What do I call this? Query.sql. Okay, so that one, still pulling out data, still displaying it on the screen, but takes significantly faster. So we cut it down from an average of about 0.6 seconds to an average of about 0.1 seconds. And it dips a little bit below that, but that's just because it's got it in cache. So maybe this goes up to 0.2 seconds when it's not already in cache. But that's pretty fast. I like that. If I'm doing a web app, I mean, just think. I mean, I don't know how big your web apps are, but maybe you don't even need MySQL, depending on your number of users and configurations. I mean, maybe if you could just use SQLite with full text search to speed up some of your slower queries. I mean, and that's really simple to back up and really, really simple to use. You could cut weight and maybe gain performance. I mean, I'm not saying go do it, but maybe test it out and see if it works for you. So I already kind of explained the whole delete and update triggers. So I'll skip over that part. Now, the next part that's a little bit tricky. Yeah?
5 more minutes.
5 more minutes? Okay. So maybe I won't be able to get to doing the module. But the next part that's a little bit tricky here is that we weren't ranking anything. We were just pulling results, right? And those results come back in any order. We don't know how important they are. So there's some built-in features that make that a little bit easier. Let me see if I've got an example down here lower. I don't think I referenced it here, but there's this thing called match info that allows you to be a little bit more selective about what you're pulling out. You can do some of this Boolean type logic. So I'll just copy this. No, that was not what I wanted to do. SQLite. There we go. So that one's taking a little bit longer there. So maybe a little bit longer than I'd like, but it's doing a little bit more. It's doing some Boolean logic. The other thing, I'll just point you to what this is, since I didn't have time to get to it. It is, I've got another repository with a little bit of a tutorial called SQLite3 FTS4 rank. And like I was saying, you can build a custom module. For whatever reason, they did not include a common rank function in SQLite FTS. On the documentation page, they give the whole block and they're like, here's a rank function that would work for 90% of all users for a basic setup. And then it's like, we didn't decide to implement it, and we're not going to tell you how to make the module, but here's the code that would go inside the module if you knew how to make it and compile it. So I just added a little bit more information on, well, I give an example of what the rank function looks like, pretty much taken from theirs with a few things modified, and then what the make file looks like, so you know what you need to do in order to actually get it to compile and link against your libsql. So that's kind of the last step in making full text search great, is getting that rank function implemented. And I'll just go down in the meat of this function real quick so I can at least mention a little bit of it. It's in C. You get past a context, which is basically the database, because you could have multiple databases open at a time. So the context refers to your archive.SQLite or whatever. And then you get an inval, which is the number of values that were passed into the function. and then you get an array AP-val, which is the actual array of characters, the array of characters that were the arguments that were passed into the function. And I believe I gave a super simple one as well, or maybe it's linked to here. But I gave a really simple example of just creating a function that adds. So you could just do select add 1, 2, and then it would return that to you. So that's there as well. So sorry we weren't able to get to that, but hopefully this was useful, and welcome to full text search. Any questions?
You had an index to the database. You got the speed improvement.
Yeah.
And it looked like you did a batch here, right? Is that, can you do that dynamically in the background? When does that happen?
So you have to create the index once with this statement right here. But once you've created the index once and you've created the triggers, so both of these files are in the repository. This is just a clone of the repository. Once you've created, so the first time you do the index, it has to run on the whole database, and it takes a long time. If you ever change the way you want the index to work, which fields you want it to work on, etc., you need to rerun that indexer, and it's going to take a long time. But then, once the triggers are in place, it's just every time something updates, it automatically, well, because of the triggers, is updating the index.
How long does it take to update? Like if you have a constantly changing database, do you want to use something like this?
You want to be selective about what you're indexing, because every time you index, there is a performance hit on that update.
Okay.
So it would make more sense for data that is less likely to change. Like, for example, Facebook posts. People post something, they're not likely to click the edit button, but they may. That kind of environment. Other questions? Oh, and also, I don't know if I introduced myself. I'm AJ O'Neill. My handle is CoolAJ86. I have a DJ company. If you ever know anybody out in the way, you can give me a call. It's AJ the DJ. I also have a tall men's clothing company. I also have a JavaScript consultant. So.
Thank you, AJ.
Thanks.
You're welcome.
Thank you.
Thanks for being in here and pretending at least to be attentive. And I'm sure some of you were, maybe most of you were attentive. I don't know.
So did I say that SQLite